Top of the morning to do on this beautiful day. What we're going to do is take a gander at looking at perimeter and area of similar figures. So by way of exploration, we're going to see how the ratio of the areas of any two similar figures compare to the scale factor. So we're told that these figures here are similar. Oh, and this one here. And what we're going to do is break it up into smaller components, and we're going to figure out how large everything is, etc. So the area of the large, so for this guy, rectangle 1 is right there, and we can see that that one is 18. And I'm going to ignore units for now, just to keep it clean. Same thing here, rectangle 2 is also 18, and rectangle 3 here is 9. All right, now the small one over here, this one here is an 8, so is the 2, and the 3 is a 4. Now when we consider scale factors of things, what we're looking at is this side here compared to this side here, just corresponding elements. So for the first one there, it's just a 3 compared to the 2. Next, looking at the other one, we can say, oh, this guy here compared to this guy here. So if you did that one, you didn't have to choose those two. But 6 to 4, which becomes 3 to 2. And we can write those as fractions if we need to. Rectangle 3, which is also a triangle, or excuse me, a square. This guy here compared to this guy here, also a 3 to 2. All right, now if we look at the adding everything up here, all three of those add up to 45, and all three over here add up to 20. So the initial is 45 compared to 20, and then of course, oh, excuse me, that's for the areas. So that would be 45 over 20 in this column, and we'll get back to that in just a second here. Now when we compare the areas, this is 18 compared to 8. So 18 compared to 8, which reduces to 9/4, or 9 to 4. And the same thing here, 18 to 8, and that's also going to be a 9 to 4. Lastly, 9 to 4 does not reduce any further. And the last one does reduce, which I can do now, to be 9 compared to 4. The scale factor of the entire shape to the entire shape, actually, again, does not matter how we count it. All I do is choose one side that corresponds to another one. The top corresponds to the top here, the side one here corresponds to the side there. And all of them, no matter which sides I choose, I'm going to get 3 to 2 on that. So let's see about a pattern here. 3 to 2, 3 to 2, 9 to 4, 9 to 4, 3 to 2, 9 to 4, 3 to 2, 9 to 4. So let's make a conjecture. If two polygons are similar and have a scale factor of A to B, or A over B, then the ratio of their areas is A squared over B squared. And that's how we compare areas. Now to find the perimeters of these figures real quick. Now when we consider the perimeter of the area of figure 1, it's 36 units. And the next one is, I believe, 24. And so if we looked at that, what's the ratio of their perimeters? Well, it might be easier to see as a fraction, 36 over 24, which reduces to 3 over 2. Nicely done. So how does that affect, or how does that compare to the scale factor? It's exactly the scale factor. So the ratio of their perimeters is the scale factor. And the reason for that, actually is a straightforward response here, is that this is to the power of 1 because it's a linear measurement. I'm just counting how far around something is, how far I walked. I walk 1 mile, 6 inches, something like that. So that's a linear measurement. And these ones up here are not linear measurements, they're square feet. So it makes perfect sense that we're going to have a square relationship. Let's jump into an application of it and then come back to more straightforward textbook sort of stuff. All right, example A here. A small 2x3 rug costs $10. What would you expect to pay for a 6x9 rug? And let's make a quick adjustment here. Let's say that the rugs are similar. It's already true. We can tell by side angle side or whatever that they're similar. But why are the rugs? But let's be specific that the rugs are indeed similar. All right, so, or that they are. All right, so now, what's the relationship? Well, if I look at the scale factor, a 2 compared to the 6. Notice I'm just comparing the small sides. So the scale is 2 over 6, which is 1/3. 1/3. So what does that mean about their areas? What it means about the areas is that they are 1 squared compared to 3 squared. And that goes to 1 over 9. So practically speaking, what does that mean? That means that if I take 9 of the smaller rugs and sewed them together, I would get 1 of the bigger rugs. 9 of the smaller equals 1 of the bigger, sorry. So just to show you how it breaks up, and you can go by diagramming here. So if this is not 6, that's the 9. If this is a 9 by 6, and I want to figure out how many 2x3ers fit inside, it would be something like this. So each one of these guys here is a 2x3. Each one of these is a 2x3. And so clearly we see that we have 9 of them. So what would we expect? If one of them cost $10, what would we expect the large one to cost?
90.
There we multiply by 9. So we expect $90, as at least monetarily, straight numbers. In real life, we would expect to pay less just because our experience shows us that the more you buy, the less you pay. Hence the reason for Costco and BJ's and Sam's Club. All right, you take a gander at this next one here. It took James 5 hours to paint an 8x24 foot wall. At this rate, how long will it take him to paint a 12 foot by 36 foot wall? So it's another wall. He's not continuing to paint. It's a new wall. So first off, the scale factor we clearly see is 8 to 12, so that becomes 2 to 3. When you square that, you get 4 to 9, and that is going to compare to the work. So this here is how the areas compare. So this one, the fraction I'm going to do here, is how the time spent compares. 5 compares to x there. So now when we cross multiply, and by the way, that's what we did over here. We did do cross multiplying, we just didn't show the work, because I say 1 compares to 9 as $10 compares to the unknown. So it probably would have been best if I had shown that on that problem there. So now when we cross multiply and solve, we get approximately equal to what?
11 and a quarter hours.
All right, so 11 hours and 15 minutes, something like that. Let's take a gander here. The figures in the pair are similar, so that's the key. They always have to be similar in order for this rule to work. Compare the first figure to the second and give the ratio of the perimeters and the ratio of the areas. So the ratio of the perimeters is going to be 8 compared to 6, which simplifies to 4 to 3. So there we go. How about the ratio of their areas? All we do is square that. That's it, 16 to 9. And we're done. Get her done. So how about this one? Let's now use that information, and what we're going to do is find the area of the other to the whole number. And what's the problem with these ones? There's no area put on them. So, all right, so that's rectified. So change this one. This is now 12 square inches. So now, what's our relationship? Well, we know the scale factor is 4 to 8, which reduces to 1/2. Now, that converts, when you compare the areas, to 1/4. Again, practically speaking, that means 4 of these little guys can fit into this big thing here. All right. Now, how do we use that? Now I take the 1/4, and since the 12 corresponds to the small, I'm going to place that one on top, and then find the area of the other one below. You can cross multiply or whatever. It's actually easier just to say times 12 that way. So times 12 this way. So the area of the large one has to be 48 square inches. Like so. So take a moment to work on the other one, given that this one is an area of 72 square feet. Last thing we want to look at here is we're going to find the scale factor given the actual areas. So if we have the actual areas, 144 compared to 36, and if I reduce that, I get 4/1. And now what you have to do to go the other direction is that you have to square root. So what's the scale factor? The scale is 2 to 1. And that's it. So not such a big deal. Instead of squaring, we're square rooting after we reduce.